Hi and Assalamualaikum. We are from Group 15, Section 7, and today we will be presenting problem-based learning for statistics. Our group consists of 5 members, which is Muhammad AFHAM bin Muhammad ZAIDI, Nur AZYYATI, Siti Aisyah ANASYA, Muhammad Emir Syamin, and Nur EDYRA SOFEA.
Assalamualaikum warahmatullahi wabarakatuh and good morning. Introduction. In statistics, simple linear regression is a statistical method that allows us to summarize and study relationship between two continuous quantitative variables. Simple linear regression gets its adjective simple because it concerns the study of only one predictor variable. Meanwhile, multiple linear regression, which we study later in this course, gets its adjective multiple because it concerns the study of two or more predictor variables. Regression models describe the relationship between variables by fitting a line to the observed data. It allows you to estimate how a dependent variable changes as the independent variables change. Simple linear regression is used to estimate the relationship between two quantitative variables. You can use simple linear regression when you want to know how strong the relationship is between two variables and the value of the dependent variable at certain value of the independent variables.
I will explain the filler table. First of all, we look at the 3 facts of the question. First, record information from nutrition labels of a variety snack foods. Second, explore the relationship between fat contents per serving and calories per serving. Third, analyze the data and interpret the results. We continue with the second and third content in the filler table, namely ideas and learning issue. For ideas, the first one is collect data directly. Second, to know the nutritional facts of each snack. Third, find the value of R2 using the simple linear regression formula. For the learning issue, first, create a scatter plot of this data between fat contents and calories and describe the relationship. Second, what is the explanatory variables and response variable? Third, write the fit model using mathematical notation and interpret the slope and intercept. 4. How to determine value of R2. The last one is resources needed. First, build the questionnaire. Second, identify the good way to write up the questionnaire. Third, buy references book. 4. Collect and record 26 data for fat content per serving and calories per serving. That's all from me. Thank you.
Based on the PBL question, we were asked to explore the relationship between fat contents per serving and calories per serving from a variety of snack food. Based on the table shown above, these are the data that we collected from 25 snacks food. Question 1 asks to create a scatter plot based on the fat contents and calorie and describe the relationship. Hence, the x-axis is fat contents can be described as the independent variable, while the y-axis is calories can be described as the dependent variable. As fat contents increase, the calories increase. So, the relationship between these variables is moderately strong and linear with no apparent outlines. Next, to solve the upcoming equation, we have searched the value xy x to the power of 2, y to the power of 2, and xy as you can see from the table.
Okay, then I will present the problem and solution section for question 2, 3, and 4. In question 2, we were required to describe what is explanatory variable and response variable and explain the use of simple linear regression in solving this problem. Based on the scatter plot, the explanatory variable is the fat content, while the response variable is the calories. Simple linear regression had been used to display the relationship between two quantities variables. It's also used because it can display how strong the relationship between fat contents per serving and calories content per serving. Question 3 asks to fit a simple linear regression using mathematical notation, interpret the slope, intercept, and sketch the line. To solve the upcoming equation, we had searched the value of x, y, x to the power of 2, y to the power of 2, and xy as you can see from the table on the slide before. We answer the question by using the equation of y hat equal to beta hat none plus beta hat 1x. To To find the value of beta head 1, we use the equation of Sxy divided by Sxx. Sxx is solved by using the total summation of x to the power of 2 minus with the total summation of x powered by 2 divided by n. The gain value is 144.974. Next, xxy is solved by using the total summation of xy minus with total summation x multiplied with total summation of y divided by n. The answer is 1743.044. Then SYY is solved by using total summation of y to the power of 2 minus with total summation of y powered by 2 divided by n. The answer is 29,929.76. Based on the equation of beta head 1 is equal to Sxy divided by Sxx, we use the answer to fit into the equation. Hence, beta head 1 is equal to 12.023. For beta head 9, we use y bar minus beta head 1 multiplied with x bar. As you can see, the answer for y bar is 121.64, while the answer for x bar is 5.716. Using the answers, we feed the value into the equation and we gain the value of beta head 9 equal to 52.915. From the values that we had gained, we feed the answer of beta head 9 and beta head 1 to the first equation to find the y head. Hence, y head is equal to 12.023x plus 52.915. This is the line that we had sketched using the interpret slope and intercept. Question 4. Find interpret the value of r to the power of 2 using the equation of r equal to sxy divided by the square root of sxx multiplied with syy. We gain the answer of r equal to 0.8368. Then, we put the power of 2 to the answer and gain the value of r to the power of 2 equal to 0.7002. Based on the answer, the accuracy of the data is low because r to the power of 2 is lower than 0.75.
Now I'm going to talk about discussion and conclusion. In brief, we were able to investigate the relationship between fat content and calories using the knowledge we gained from simple linear regression. Firstly, from the scatter diagram, we could see that there is a relationship between them as there are no apparent outliners in relation between fat content per serving and calories per serving, which is moderately strong and linear. We use mathematical notation to interpret the slope and the intercept by applying the formula y head equals to BO head plus B1 head x. Then by applying the knowledge in correlation, we measure the strength of the relationship in numerical values. The value is 0.368, which shows a strong positive correlation relationship. Besides, through the least squared method, we obtain a least regression line for the relationship. The equation of the line is y equals to
12.023x minus 52.915.
Furthermore, the coefficient of the determination, which is r squared, is 0.7002. Thus, that the accuracy of the values in the data is low as it less than 0.5. A low figure is generally a bad sign for predictive models. However, in some cases, a good model may show a small value. That's all for me. Thank you. Now I'm going to show you how I collected the data from the snacks. Firstly, this is from the nutrition information. Here.